In Kenya have made a discovery of a lesser mealworm that has the potential to consume and survive on plastics. Sheilar Chelangat visited the International Center for Insects Physiology and Ecology and filed the story of this tiny insect that offers hope in the fight against the plastic menace. Take a look.
Here at the International Center for Insect Physiology and Ecology, scientists have made a discovery, that of a mealworm that can consume plastic. Could this be the solution to the plastic menace in Africa, being that it is one of the most polluted continents? The larvae of this darkling beetle species has extraordinary ability. It not only consumes the plastic, but also survives on it. Dr. Fatia Khamis has been the lead senior scientist of this project.
We came across this mealworm in the chicken coops where we were doing research. So we picked it as a larvae in the litter in the chicken coops. And this is also a well-known pest in storage grains, where the beetle feeds on storage grains. We knew this is one of the darkling beetle mealworm, which is actually a close relative to other mealworms in other parts of the world. Elsewhere, like in US, they've used this yellow mealworm to degrade or digest plastic. So when we saw this, we said, why not put it also on plastic to see what it will express? And here, this is what you see. It feeds on plastic.
In Nairobi, Kenya, approximately 2,400 tons of solid waste are generated daily, of which 20% of it is plastic. Most of the city's waste end up in these mountains of landfills, choking communities living around it. In the study, this mealworm has been found to have the potential to digest polystyrene, a major microplastic that has found its way to such landfills and water bodies.
We started with styrofoam because this is common for us. We have equipment and this is some of the packaging that we have. As a starting point, we kept it overnight to see if it actually will feed on this. Yes. Then now we did experimental setup where we did just keeping them on styrofoam, and after 30 days, it was progressing with its life cycle. So it was surviving and it was nicely feeding on styrofoam. Of course, we also had other setup to see the longevity of this insect. When you mix the styrofoam and other maybe the normal diet that we give them in the lab.
So does this non-poultry pest gain any nutritional value from the plastic?
When on plastic, it was also feeding and surviving. And when we mixed it, maybe the plastic with the normal wheat bran, it was also surviving. And of course, we were putting a source of liquid, which is the fruits. So the survival on the normal diet, it was slightly higher, but not significantly different from the styrofoam. It means they're getting or they're exploiting something in the styrofoam that is making them survive. Because they were surviving, probably it's the carbon and hydrogen in this, which is a source of energy for them. But what we know is it's feeding on it. So it is digesting in its system. What we say, why we say that it is digesting it, because when you keep it all alone on just on the styrofoam, it was feeding, surviving, and even going toward to another life stage. So actually, we know that it's getting some energy or from the styrofoam.
The quest of understanding the potential of the larvae did not end here, as the researchers sought to understand the process with which the larvae digests plastic.
As they are feeding on the styrofoam, there's elevated levels of bacteria, which are well known to degrade plastic. And when now we did extraction or the dissection of the insect to get the gut content, actually we got higher level of bacteria that are well known to be degrading plastic. Now these are the bacteria that we want to go a step further to isolate them and see in isolation or in a consortia, can they do this work? Can they degrade the plastic? Or maybe we go even a step further to see if we can express these enzymes and we use them as scalable products for plastic degradation.
Also under research is whether these bacteria are part of the worm's natural gut or whether they are acquired by feeding on plastics.
And the mealworm, after feeding on plastic, it was not retaining, there's no bioaccumulation of the plastic in their body. But in the frass, which is the excrete from the larvae, they found out that it has some toxins in the frass. So all this we have to do, especially for our insect in the African setup and in our environment, to see if it will have bioaccumulation or is it resistance to this, and what is the effect.
You tried the experiment with the styrofoam, but have you tried other forms of plastic?
Yeah, we are now trying to put cellophane, and it's actually feeding on it. Yeah, so yes, but this has to be set up as an experiment for us to know the different kind of plastic that it can degrade or digest.
And according to Fatia, more research is needed to harness its potential of tackling plastic waste.
As you've seen in our labs, it's not easy and it's very cumbersome to pick a lot of mealworms for the degradation. In our experimental setup, we were putting around 100 to 150 for just a small piece of 3.6 grams of styrofoam. So will this be conducive to pick millions of mealworms for this work, to do the plastic degradation? But for us, the way forward is to produce the bacteria or the enzymes. Our research is heading towards production of these bacteria in isolation or in a consortia that can do the degradation of the plastic. We can harness these benefits of the mealworm, use it as a source of food, source of feed, source of organic waste degradation, and also source of organic fertilizer. But now with this discovery, we can go further and have also maybe entrepreneurship where we can also harness the mealworm for the bacteria or for the enzymes to now reduce the menace of plastics in the environment.
And as scientists continue their research of this tiny insect, for sure it offers a glimmer of hope in our fight against environmental degradation. Sheilar Chelangat for TV47 in Nairobi.